Hey Chemistry, Mrs. KJ here, and I am going to go over with you lesson 4.01, and that is going to be making ionic compounds. So what are ionic compounds? When two atoms bond by exchanging electrons. So both atoms have a full outer shell and are now in a stable neutral compound. Okay, we have a lot of key words going on in this sentence. First of all, we need to have at least two types of atoms or elements. Okay, they are exchanging electrons. So that means that one is going to be losing electrons and the other one's going to be gaining an electron or electrons. And so simply when we say gaining or losing, since both are going on at the same time, we say that they are exchanging the electrons. Why? Both are now going to have a full outer shell. Why? To be stable. And it's going to be part of a compound, and specifically that whole entire compound is neutral. So we're going to be taking the one atom that loses its electrons, which is the cation. That one's going to have a positive charge, and we always write that one first. And the other atom is going to be gaining the electron, and that's the anion, and it's going to have a negative charge. But when you put together this positive charge along with the negative charges, it's going to end up being an overall total of 0. And so the compound as a whole is going to be neutral. So there's a few different ways that this can be taught, and I figured I would just start out by doing a bunch of examples. So if you feel at the end of this lesson that you're like, whoa, I have no idea how you did this, let me know and I will make another video and teach it a totally different way, and I'm okay with that. I've been going back and forth over the last 3 days about which way to go about teaching this. So let me know, and we'll just start by doing some examples. All right, so let's start off by looking at the periodic table. Obviously, there are many periodic tables that you can use. And of course, there is the one that I gave you. And there's a reason that I gave you this one. We know that things are color-coded, so you know that all of these are metals, except for hydrogen, which is a nonmetal, and the rest of our nonmetals are over here. We have our metalloids splitting them. That's really important. When we make ionic compounds, we are going to have a metal paired up with a nonmetal. So it's important to know the differences between your metals and nonmetals. And then also on here, I have our very important word, valence. Valence or outer electrons are gained, lost, or shared, so the atoms have a full outer shell and are stable. So again, group 1A, every single element in this group has how many valence electrons? 1 electron in the outer shell. So if we would draw the Bohr diagrams, all of these would have 1 valence electron or 1 electron in the outer shell. Group 2A, all of these have how many valence electrons? 2. Group 3A, because we skip the middle messy transition metals, because these guys can have multiple charges, and we'll talk about these guys later. So group 3A has how many valence electrons? 3. Group 4A has how many valence electrons? 4. Okay, group 5A has how many valence electrons? 5. Group 6A has how many valence electrons? 6. Group 7A has how many valence electrons? 7. And the noble gases all already have a what? A full outer shell, which in the case of neon down means they have 8 electrons in their outer orbital. Helium only has 2 because it's so tiny, it only has 1 orbital and only 2 electrons fit in that first orbital. All right, so we are going to make an ionic compound. Again, an ionic compound means that we are going to be exchanging electrons. So that's the other part of this periodic table that's super important to this. Since group 1A has 1 valence electron, is it going to lose 1 or try and gain 7 to get a full outer shell? It's going to lose 1. And if it loses 1, the charge is plus 1 because now it has less negativity. It has less negative electrons, and overall charge is more positive. Group 2, 2 electrons. Are they going to lose 2 or gain 6 to get a full outer shell? They're going to lose 2, which is going to give it this plus 2 charge. Group 3, 3 valence electrons, it's going to lose all 3 of these in order to have a +3 charge, in order to have a full outer shell and be stable. So let's look back at another periodic table, and I just pasted these in on top of these so that we could easily see our patterns. And remember, our pattern is quite simply group 1 has 1 valence electron. So even though hydrogen only has a total of 1, lithium has a total of 3, and sodium has a total of 11 electrons, when you put them in the Bohr diagram, 2 fit in the first orbital, then up to 8 in the next orbital, and there's always 1 left over in this group. This group always has 2 left over. And I did the same thing over here. I put them over there, shrink them down a little bit to size. There we go. And again, you can see the pattern of your valence or outer electrons, which in these pictures are always in red, and that's what's super important. Now, the other thing we're going to get to is called the octet rule. So let's talk a little bit about what the octet rule is. Now, when you see the word octet, what do you think of? Hopefully you think of 8, like octopus. Okay, so the octet rule, there we go, sorry about that, is the rule of 8. So what do you think that's talking about? Well, that's talking about when you have a full outer shell, it wants a total of 8 valence electrons. So, for example, when we are talking about losing electrons, if I lose lithium's electron, not only do I lose that electron, but I lose that whole orbital around the outside. And when I lose that whole orbital, now the next orbital is my full outer shell. Just like with sodium, if I lose this orbital, now it only has 2 orbitals left, and that one's full. Okay, if I go to magnesium, it's got to lose 2 electrons now. It loses that outer orbital, and the next orbital is full. That's why it has a full outer shell. So hopefully a lot of this so far is review, because this comes into play with how to make ionic compounds. All right, so let's go ahead and get to these examples that I promised. All right, let's pick 2 elements. Let's start out with lithium, and let's combine lithium with sulfur. So what do we know about lithium? Lithium is in group 1. How many valence electrons does it have? 1. Is it going to gain or lose electrons? Well, it only has 1, so it's going to lose that 1. After it loses 1 electron, what is its charge? Positive 1. All right, and we're going to put that with sulfur. Sulfur is in group 6A, so it has 6 valence electrons. Is it going to lose all 6 or gain 2? It's going to gain 2 electrons to have a full outer shell. And what's the charge going to be after it gains 2 electrons? Remember, electrons are negative. Think of them as bad, if that helps. And we gain 2 of those awful, horrible things. So now I have a -2 charge. Okay, now is where you can do this one of 2 ways. And the first way you can do this is by looking at the Bohr diagram. So that's how we're going to look at this first, because it really explains the why and the how of all this. So as I said, lithium is going to lose this 1 electron. So, okay, no big deal. This electron is going to go over here, and it's going to fit right in there by sulfur. And so it's going to be happy because it says, hey, no big deal. I didn't want to really be here anyways, so I'm going to go right there. And lithium's going to lose this outer shell, which of course it's not letting me do. Lithium's going to lose that outer shell. Its first shell has 2 electrons. That's all it takes to fill it up. It's full. It's happy. Woohoo! I'm done. And sulfur says, no, you're not. You promised to help make me stable. I still have 1 empty space. You need to help out. And lithium says, well, there's nothing I can do about it. However, I can call over my twin. And so lithium actually calls over another lithium atom. And that lithium atom also has how many valence electrons? Just one, because it's in group 1. And the same thing's going to happen. This electron's going to go down here. Woohoo! This orbital is going to disappear. Full outer shell, it's happy. Full outer shell, it's happy. Full outer shell, it's happy. Ooh, ooh. And yes, the atoms really do make that sound every time it happens. And so you can see now everybody has a full outer shell. Well, it took 2 lithium atoms for every 1 sulfur atom. All right, so that means when we write the chemical formula, we're going to say lithium, well, it took 2 atoms for every 1 atom of sulfur. If you want to write the 1, you can. You don't have to, but if, especially starting out, if it makes you feel better, write the 1. I don't care. I'm not going to mark it wrong, but you don't need it. So this would be our chemical formula. Now, if you're thinking to yourself, are you kidding me? I have to draw this out every single time? No, you don't. Because we can look at our charges and we can say, all right, so lithium had a charge of +1. I'm going to take that 1 and I'm going to write it right down here. Look at that. This +1 charge ends up telling me that I need 1 atom of sulfur. Okay, then we're going to look over here and say, well, okay, it took 2 atoms of lithium. Where'd that 2 come from? Well, there was a -2 charge, and we're just going to write that 2 down there. So now it tells me that there's 2 atoms of lithium. It kind of looks like cross multiplying in math class. So that's all you have to do, and that explains why. So that's how you make an ionic compound. You simply write the charges, and you do what looks like cross multiplying to make those numbers into subscripts. And now these numbers are both positive because now it's not the charge. Now it tells me there's 2 atoms of lithium, 1 atom of sulfur. Why? Because sulfur had a -2 charge, so it needed 2 electrons. Lithium had a +1 charge, so it had 1 to get rid of, but because there needed to be a total of 2 to make sulfur happy, it took 2 atoms of lithium. And that's it. That's all there is to it. So you now know everything you need to do the worksheet. And then, as always, check your own worksheet. As always, if you have questions, let me know. And I would be more than happy to go over them with you. Now, if you're thinking to yourself, wait a minute, you can't be done. I totally did not get that. That is okay. I am going to do a few more. But if you're like, oh yeah, totally got that, go ahead and you can do the worksheet now. All right, so let's pick somebody else. Let's pick magnesium. Magnesium. And let's put magnesium together with nitrogen. All right, magnesium has what charge? It's in group 2, so it has a +2 charge. Nitrogen is in group 5, so it has 5 valence electrons, which means it needs to gain 3 electrons, which gives it a -3 charge. Okay, and then we put it together. Now we do what looks like cross multiplying. And we say, all right, let's take that 3 and let's put it down here. And so after I do that, I have Mg3. So I have 3 atoms of magnesium. And I take this 2, I write it down there. I have 2 atoms of nitrogen. So it takes 3 atoms of magnesium to make every 2 atoms of nitrogen happy. And my formula is Mg3N2. All right, now let's do Mg again. Group 2 has a +2 charge. Let's put it with oxygen. Oxygen has a -2 charge. And you get Mg2O2. And we can actually reduce and just write MgO. Oh,